So whether you bought the full kit or are sourcing parts yourself, this is everything that you should need. Alright, so we're going to start with the frame and the eye pivot. These two pieces should initially just snap together and be held in place with friction, and then they're going to be secured from the rear with a 6mm Phillips head screw. And you do want a smaller Phillips head screwdriver that's kind of long and slender, but those just secures from the back. And you want to make sure you get it pretty tight so that the thing doesn't move, but you also don't want to risk stripping the screw. Next, we're going to attach the feet on the front and rear of the frame. These should also snap in initially and then be secured in place pretty similarly. And there's really no need to get these super duper tight. The screw is mostly just there to make sure that nothing slides out of place. And with that, our basic frame assembly is done. From there, we need to attach each of the servos to the frame. With each servo comes 3 screws. We're going to be working with the 2 larger screws for now. This is going to be what we use to actually secure the servos to the frame. And we do need to mount these in a pretty particular pattern. So if we hold the frame with the pivot facing to the right, we need to insert this servo so that the white part is facing us and is oriented downward towards the feet of the frame. And secure that in place with the 2 screws we set aside. And the next servo we're going to put so the white part is pointing up. So we got down, up, and the pivot facing to the right, so this side is good. Now we're going to flip over to the other side, so the pivot is now facing to the left. And we're going to put the next servo, again oriented downward. And then after that, the remaining servo needs to be pointing up, so that's the one closest to the pivot. So we secure that in place, and we know we're correct when all the servos match this proper orientation. Now we got a pretty big mess of cables, so we're going to tidy that up with some zip ties. At the rear of the frame, you should see 2 little rectangular slots. I like to do the top wires kind of by themselves, so I pull those towards the back and zip tie them together. And then I bundle those 2 top wires with the 2 bottom wires, and then secure that with a zip tie kind of out on their own. And then we trim the excess with a pair of snips. And that's looking a lot cleaner. So now we're going to actually put in our eyeball mount so that we have a good way to secure this thing to our frame and move it how we want. So I actually, in the kit, include a little tool that is to make sure that we get the mount secured in the right position. So the mount just secures into the little eye holder piece, and then it presses down into the eyeball, and it should be nice and flush, even spacing all the way around. To secure the piece into the eyeball, where I use hot glue, you could use super glue or something else, but I found hot glue worked pretty well, and you actually don't need a whole lot of glue. But basically, put some glue in the bottom of the eyeball, set the pivot piece down in there, and then use the tool to press it down, hold it for about 10 seconds, and then you can pry the little tool piece out, and you should have a nice even spacing all the way around. One of the downsides to hot glue is you get strings that you have to clean out, but it generally works pretty well for me, I found. Alright, and with that done, we can actually snap the eyeball into our frame. Should go in pretty nicely and should be able to move in all directions pretty smoothly. If it's not, then you might want to use a replacement piece. Next, we're going to put in the screws that we use to pivot the eyeball lids around. We're not going to screw those in all the way. We're just going to get them so they're barely peeking out of the 2 little side arms from the pivot piece. Next, we're going to take our 2 lids, kind of put them together, and then attach them to those screws. So I find it's easy to kind of put it in on one side, and then that will hold it in place, and then you screw it in on the other side. You do want to make sure that you don't screw in too far so the eye can't move. Alright, so next we're going to start with some of our electronics work. In the full kit, you should get a power supply that has this little handy attachment on it. We're going to start with the positive, that's the plus sign marked on there. We're going to attach a red wire on there. And then we're also going to go ahead and attach our negative side. It's going to go to our ground. Then on our servo driver board, we're going to attach our red wire to the side that says V plus, and then our ground wire or negative wire to the side that says ground. For this one, you do need a flathead screwdriver. It's the only piece in the kit that you need it for, but you know, I don't make these boards, so there's not much I can do about it. So secure these in place, make sure they're pretty tight and that they're not going to fall out or get loose anytime soon. And with that, we can set our servo driver over to the side. Now we're going to take our breadboard. If you've never used one before, basically the red and blue rails are where we're going to be getting our power from, and then the rows are connected to themselves. So we're going to take our servo driver so that it is facing to the right. We're going to plug the top pin into J1, and the bottom pin should then be at J6. So again, the board is facing to the right. And so now we're going to start actually wiring this thing up. The first thing that we're going to connect is our ground wire, and then we're actually going to skip a pin and then go to our SCL wire, then our SDA wire, and then our VCC wire. So basically we do our ground wire, we skip a pin, and then we do 3 wires, or in breadboard terms F2, 3, 4, and 6. So now we're actually going to put in our push buttons. These guys are pretty small, but we want to orient it so that it kind of bridges the gap between the two sides of the breadboard. We're going to put in both of these. It doesn't really matter where on the breadboard they are in terms of rows, as long as it straddles that center trough. So we're going to take one of our colored wires and put it in one of the same rows as one of the legs, and we're going to do that for each button. So I connected mine to the top leg of the button. And then we're going to connect a black wire to where the bottom leg of the button, that row is. Perfect. So now we're going to start wiring up all of our grounds. So basically we're going to take the bottom wire from the servo driver, we're going to plug that into our blue column that's labeled minus. We're going to take our 2 bottom legs of the push buttons and put those to ground as well. And then we're going to run a wire going from anywhere on that blue column, that ground column, over to the ground pin on the Arduino. So it's kind of hard to see, but it's labeled G and D. Alright, next we're also going to run our 5-volt line. So we're going to take one of the red wires, plug it into the 5-volt line on the Arduino, and then plug that into the red plus rail on the breadboard. We're going to take our topmost wire from the servo board and plug that into that same red positive voltage rail. So next we're going to attach our SDA and SCL wires from the servo board to the Arduino, as well as the 2 signal wires that we had for the buttons into pins 2 and 3 on the Arduino. With that, our wiring is good. So we're going to start plugging things in. We're going to power up the servo board first, plug that into the wall, and then plug in your Arduino into your laptop. Okay, and we're going to begin by opening our iMac user guide that you can download. It should look something like this, but we're going to go to the Arduino code section. We're going to open that up. We're going to go to our very first file. It's our wiring check file, and we're going to open that up. Luckily, I've already got that open. You do want to make sure that you have your Arduino plugged into the computer that you are doing your coding on. And basically all that this code does is it makes sure that your buttons are plugged in to the right places and that they can actually read a clip correctly. And it also will send power to that servo board so that we can get our servos oriented in the right position so that we can start attaching our linkages. So what I'm going to do is I'm going to go ahead and send that code over. It's going to upload to the Arduino, and then I'm going to click up to this right corner. It says serial monitor. Put that over here. It's telling me that we're ready to go. And then I'm just going to reach over and click the button. We'll see that the look button works. Then we'll go and press the other button, and we can see that the blink button works. So now we're sure that our wiring is correct.
and we can start moving forward.
Okay, so here's where things start to get fun. We need to start connecting our servos. We need to do it without any of those plastic servo horns attached. So if you accidentally attach those, go ahead and remove them. Basically, we're going to take our backmost servo, we're going to trace that wire down, and we're going to plug it in to the bottom pins on the servo board. When you plug each servo in, it should move to its home position. So here you can see that that second servo just flipped around. And note that the black color should go to the black and the yellow should go to the yellow. So our rearmost servo is going to be in pin 0 on the servo board, and our frontmost servo, the one closest to the eye, should be in pin 3. So now we're going to start actually attaching those white servo horns so that we can get a good idea of how we can make this thing move. Note that we do want to attach these pretty much up and down at the servo's natural home position, so don't try and twist the servos to get them perfectly straight. Just get it close, it doesn't have to be perfect.
Okay, so now we're going to go back to our Arduino code. We're going to go to the second file that says button blank, and we're going to open up the file that's for one eye, which is what we're working with right now. So we open that up, and if by any chance you happen to unplug your Arduino, go ahead and plug back in, connect to it, and we're going to upload this code. And when you press the blink button on the breadboard, you should see the mechanism move.
And so those back two servos should be moving towards the eyelets. Alright, so now we're going to start what I think to be the most frustrating part of this project. We're going to start bending the linkages. So on your little linkage bending like template type thing, you're going to take some of that steel wire, and there's two pieces on there that are just like a basic stretched out straight Z shape. So go ahead and bend one piece of wire to the longer Z shape. This is going to be what controls our top eyelid. And then bend another piece of wire to the smaller stretched out Z shape. So just press it on down in there. You want to keep these as straight and as flat as you can. And these will take a little bit of tweaking to get everything fitting right. But go ahead and bend that in and then snip it roughly to length on the template. And so we're going to start with the shorter linkage piece. This is for our bottom lid. We're actually going to feed it in from behind the servo horn into the bottommost hole. And then that just reaches over and connects into the eyelid. It may be a little loose, but we'll fix that in a minute. We're going to do the same for the top eyelid. And then what I like to do is I like to get a pair of pliers and then kind of grab the little bit that's poking through the horn, pull it out as far as I can, and then bend it away from the eyelids, bend it away towards the back of the mechanism. What that does is that adds tension so that the linkage is always pressing into the eyelid so that it doesn't pop out. We're going to do the same for the bottom lid. You can see just the level of tension that's in there. It actually wants to press inward. So we're going to go ahead and connect that. Then you might have to tweak the top linkage a little bit to make it clear the servo that's right next to it. So I like to add a little bend in there. And after that, you want to make sure that everything is as straight as possible in terms of a straight line from the linkage to the servo when you're looking from the top. But other than that, we should be able to blink.
You are going to need to change some of these levels. These define the limits for your opening and shutting of the eyelids. So I've said here that this is the shut limit, this is the open limit. So if you need your eye to be more open, make this more like 410. If you need your eye to shut a little farther, go ahead and make this closer to 300. If it's too far down, then bring it up a little bit, and so on and so forth.
With that, we can go ahead and screw in the little servo horns using the tiny screws that came with each servo. We do that, make sure everything works, and we should be able to move on to the other side.
So now we're going to go and open up the third file, which is lookxy. We're going to do this with one eye. We open it up. Make sure that our Arduino is plugged in. Upload the code. And then when we press the button, we should see the Arduino beginning to move the other servos. And then we're going to actually connect these up. So we're going to bend our linkages for the X and Y movement servos. We're actually going to start with the longer zigzaggy shape on our bending template. Go ahead and bend that all the way around and trim to length. We're going to do the same for the shorter zigzaggy shape. These are actually what are making up our X and Y linkages. So our X linkage is the shorter one and our Y linkage is the longer one. And these can take a little bit of effort to get just right because you do have to do some tweaking on them, some extra bends and that type of thing. We go ahead and trim this to length, take them both out, and then we're going to actually start with the longer linkage. So we're going to set the short one to the side. We're going to take the longer one. We're going to start by taking the short curly end and bending that 90 degrees towards the longer end. So we're going to bend it up. And when you get that finished, if you look from the top, the short end should be in line with the rest, and the longer hook should be laying flat, and then if you look from the side, it should be the other way around. So we're going to hit the longer hook through the top horn of the second servo. And this is going to take some tweaking. We want to make sure that first little straight bit is nice and flat. So I actually like to bend this in with the pliers, make sure that it's not going to go anywhere. We only want it to be able to rotate in along one direction. So we want to make sure that first little straight bit is parallel to the rest of the frame. So I'm going to bend that a little bit. I also bent it up just to clear the servo next to it a little bit as well. And at the end, the shorter hook should be in line with the center line of the frame, pointing perfectly up and down. We're going to do a similar thing for the X-axis servo. So we're going to put the longer hook through the bottom hole of the servo horn, and then kind of pinch it, crimp it down a little bit with the pliers so that it can only bend, or it can only rotate in one direction. And so now we'll actually need to bend this piece upwards, so kind of like a Z shape. So we're just going to take both of the flat sides, pinch them real hard, and then just move straight up so that we get a nice little Z shape. That hook should be about midline between the edge of the screw and the little pivot point. Once that's done, we can actually connect the eyeball through those little holes. This can be a little tricky. Sometimes it's easier to take the entire horn of the servo off, connect it to the eyeball, and then put the horns back on the servo. But either way, you connect the linkages to the eyeball as well, and then you pop the eyeball into the little ball and socket joint that's attached to the frame. And at that point, we're ready to start kind of tweaking these linkages and make sure they get in the right spots. So once again, we're going to go back to our look XY code. And just as before with the blink, we're going to have to change these limits so that we make sure that our eyeball isn't going to go too far in the left, right, up, or down direction. These are really important because if you go too far, you can actually break either the little eyeball attachment piece or the pivot point. So you want to be kind of conservative with these and work your way up to what you think might be the good limits of your design. And so there's a couple different ways that you can tweak these to get them moving super well. I actually noticed on mine that I had my servo horn in a kind of not ideal orientation, so I went and moved it over by one little click. I also, was constantly fidgeting with some of these different linkages and stuff. You can really stiffen up your linkages a lot by going ahead and putting the screws in once you're sure that they're not going to collide with anything. And I also found that crimping it a little bit extra helped a lot. Once that was done, I got the thing moving very reliably and in a way that I really liked. So I go ahead and reattach the eyelids and reattach the linkages into the eyelids. And I recommend you load the look and blink
Arduino code just to make sure that nothing is going to collide. From here, you can tweak your limits and ranges to make sure that your eye always ends up centered at the end of each motion. And once you've done that, you're kind of off to the races. You can start doing pretty much whatever you want with your eye mechanism. So that completes the basic instructions for putting this thing together. As always, there's lots to explore with the code in terms of unlocking the potential of this mechanism. You could have this thing triggered by things like motion sensors. You could run it manually using buttons or controller or that type of thing. Or you could set a routine or just have it cycle through random expressions and moods and that type of thing. There is some sample code that kind of is designed to get you started. But either way, this kit is homemade. This is my first try at this type of thing, so I understand there might be some difficulties here and there. As always, leave a comment or send me a message or feedback or that type of thing so that this can improve in the future. But thank you for checking out this project and for supporting a good cause.